Good afternoon, everyone. Welcome to join our session to debugging Apache Hadoop YARN on production cluster. I'm Jim Peng from Hortonworks YARN team. I'm dev lead. Here's my colleague Jian and Xuan, are all from the Hortonworks. We have been contributing on the Hadoop YARN community for many years, and we all Hadoop committer and PMC members. So this is today's agenda. First, we'll take a quick look at the YARN in a nutshell. And then we were talking about the troubleshooting process and many useful tools. My colleague Jen will share an interesting case study on some very hard debugging issues. And also we are talking about enhanced YARN log tools. And my colleague Xuan will show a live demo. In the last, we're talking about the future enhancement for debugging and troubleshooting YARN cluster. Let's briefly look at the YARN architecture. So I think many of you should see this picture before. It's just a YARN cluster is a form of resource manager, many node managers, and application master. When you submit a job to or application to the YARN, the application master will be launched by the resource manager. After that, the application master will handle all the resource negotiation with the resource manager and launch the container on the node manager of each node. There are also some other daemons like application history server, job history server, that is for MapReduce only, and some like proxy servers, but that's not the key component. The key component in YARN is a resource manager, node manager, and application master. So let's quickly look at internal of the resource manager and the node manager. For resource manager, the main focus is on the scheduling thing, the resource. So they have a YARN scheduler there. They also have a application master service to serve the the request, the resource request. It also have the resource tracking service to management all the node managers. So their heartbeating is handled between RM and NM. It also has some client service and admin service to serve the YARN client and some admin command line. In the node manager part, most of the important thing is how to launch details of a launch container and the monitor management of the container. So most likely it's the container manager and the container monitor. Also, there's some security related stuff for the security token verification and renew. That is mostly for RM and NM. So let's look at the troubleshooting process and the tools. So when you start to troubleshooting a problem on the YARN cluster, so sometimes you found your application fail for some reason, or application very slow or even hung there. Sometimes your configuration on YARN cluster it doesn't work, or you find the API doesn't work. The worst case, you find the YARN daemons crash, like due to the auto memory issue or whatever, or log has some warning error messages that you are not very comfortable with. Or also, like Embari or some other cluster monitoring tools, or some alert to the service on that. In general, the problem type, just like show, mostly we see here due to the configuration issues or job executing things. Sometimes it's due to cluster admin or installation issues. So the process is when you have some phenomenon and you will start troubleshooting, find out the root cause, and then deliver a solution. That is overall process. This is simple, but beautiful. Let's take an example, like when we found application failed, the root cause could be container launch failed, like due to the class path issues or resource localization issues. Or it can be too many attempt failures because of networking connection issues, or node manager disk issues, or the whole node manager just reboot for some reason. And also, you can sometimes, due to the root cause, due to the application issue, like container just fail out of memory because you're in the task logic you allocate too much memory than required. Also, it's record some security issues could be there. Then you will find according to the root cause you identify, you will find some solutions, like if it's an infrastructure or hardware issue, you just replace the disk or fix the network. If it's a configuration issue, then you will be fix the configuration, and also fix a setup of the environment, maybe restart some services. Also, if it's some misconfiguration happen again and again, we can thinking maybe it's a documentation issue that we should enhance our documentation. So if it's a YARN bug, the thing we do, we will do a report to community and fix there. Yeah, this is a typical case, but sometimes troubleshooting YARN cluster is kind of just like an iceberg. The first things show up could be very small things or a totally irrelevant thing. Here's a case from a real case we find recently, that in the beginning the YARN log shows that it has too many open file in the system. It's the beginning, and gradually we found actually reason is too many TCP connections issues, because all the TCP connection will have a temporary file caching local. So this is networking issues. But if we dig in deeply on this, we'll find the most connection actually from the local node manager to the data nodes. So we know that in YARN node manager part, we have a log aggregation service that we are uploading the local log to the remote HDFS. And also we have a resource localization service, like try to downloading the related jars from the HDFS to local. So that's the two components we suspect. In the end of the day, we find several issues related to the log aggregation service, and we report to the community and fix there. The lesson we learned from the troubleshooting on production cluster is, so first, what it means for production cluster. That means, so first, you cannot just simply stop and restart cluster in production just for troubleshooting reason. So most of the operation on the cluster is kind of a read-only operation. We just need to check things, but you cannot easily change or update the configuration or the status of the cluster. In some cases, the cluster is working in the fenced network. That means we cannot log in to the cluster operation directly. We have to using some remote debugging with the local cluster admin cases. That's bring a lot of inconvenience for troubleshooting. So here's the lesson we learned. The first is in the beginning, try to get in as much as possible, useful info as possible as you can, like screenshots, log files, JSTAG, memory heap dump, etc. So get as much info as you can. So also you need to work closely with the end user, who is sometimes the issue is related to the application. Understanding how application going there, maybe it hints something. Also, it's useful if we set some knowledge base on many cases, because what we're observing is some cases or some issues will appear again and again. So if you have a knowledge base tracking that, it will be easy to fix. If possible, reproduce this cluster in the production on the local. It's more testing or backup cluster, then you can do whatever you want to find the reason underneath. Last but not the least is we suggest you version your configuration. Sometimes the user just change a little bit configuration, but the whole thing's just a change. So you need to tracking your configuration of the history Embody has some good tools to tracking that, by the way. So here's, we're talking about some useful tools for YARN troubleshooting. Of course, the first is the log. That is most important. Then at the UI part, we have embodied UI of the YARN itself. It has some UI. You can tracking some history or info. And also we have a job history server that is for MapReduce only. And we have application timeline service. With this history info, you can identify some useful information there. Also, there's some monitoring tools like Embody, helpful to see how the YARN application going on, the cluster going on there. Sometimes we need to get some runtime info like a memory dump or JSTAC or even system metrics. My colleague Xuan will do some demo later on the log command line, so I will skip this part. But the useful thing I need to mention is, by default, the YARN cluster enable the info level of log to make sure we're not print all noisy log there. So if the YARN cluster run into trouble, what do? We need to enable the debug log level, and there are several ways to enable that. If the daemon are not running, we can just simply put the config, the debug level to the YARN env. But if the daemons are running, what we do is we have two ways, a bit hack on this, because most of the user is not actually too aware of these two tools. One is command line. You are using the YARN daemon log to get or set a log level for a specific daemon or class. Like if like the resource manager, you can set daemons log, like a capacity scheduler or resource tracker service, whatever you are interested in. And for the client side, it's similar, like the daemon not running that. You can put the debug in the configuration there. So this is UI, how to set and get the runtime log level here. It's RM and the node manager and application timeline service, they're on different port number, but they provide the same service. You can put your interesting class there and set the log level you're interested. On the UI part, I think YARN UI won't introduce here because I think most of you already have experience on that. So talking quickly on the Embody UI, so you can see the cluster summary things like all the components, resource manager, node manager, and the YARN client, how's going there. You can also see the alerts like RPC connection or the node manager status, something like that. And also the health check on each node and each services. And also there's some YARN, service-related metrics showing up there. So that is UI part. This is job history server that is for MapReduce only, that you can find your job detailed information like how many tasks you launched actually, how many the map, how many tasks, a reducer, and how much data you are reading and writing by this application. If you meet the auto memory issue, you have to using some memory analysis tools like memory analyzer to see what's going wrong there. Also, there's some important metrics in the Hadoop, like RPC metrics to get RPC queue time, average time. That is hints, the networking for the RPC. Also, you can check some, receive bytes or send bytes on this. Also, there's some JVM metrics and other related metrics there. We have a documentation. I put a link there. It's quite short. Document all the system metrics on the YARN cluster. Last but not the least is the YARN top with the just like a Linux type top. When you have a YARN top, you will see how application going there, how many containers you allocate, how many is still pending on resource, extra, and you can find some useful information. Okay, so that's my part, and let's welcome Jen to talking about some interesting case studies. Thanks.
Thank you. So I will describe 2 real support cases from our customer to demonstrate how we end up debugging in the real production cluster. So the first common question we often receive from our customer is that, why is my job harmed? So how do we debug this problem? So let's first think about at what states the application could be stuck on. The application can only be stuck on 3 states. The first is the new saving state. That means the app is waiting to be persisted in the state store. So if anytime you see the app is stuck on this state, it's mostly likely that your state store is somehow broken. So you can go and check the resource manager log and see whether there's any connection error with the state store. In most cases, it's the zookeeper. The second state the app could be stuck on is the accepted state. This state, most of the time, is meaning that the app is waiting for the application master container to be allocated. And the most common reason we see from our customer is that they set the max AM resource percentage config too low. And what this property means is that only this much percentage of the resources in the queue can be used to run your application master containers. So sometimes even if you see your cluster has a lot of resources left, you will still not be able to run your app if your user has hit this max AM resource percentage limit. For example, this is a screenshot for the AM resource info. The first red box shows the AM resource info at the queue level. Here it has 4 GB max of resources, and the queue has used 2 GB application master resources. And the second red box shows the AM resources at the user level. For example, for the user JHE, it has 4 GB max AM resources, and it has used only 2 GB resources. So you should check this page whenever your app is stuck on the accepted state. The third state the app could be stuck on is the running state. Sometimes it's caused by the app is waiting for new containers to be allocated. So oftentimes we check whether there are enough resources available for the app. I will explain more detail this later on. And otherwise, sometimes it's caused by application land issue, like the app is stuck on reading and writing from the network. So here's a real case from our customer. On Friday evening, customer experienced cluster outage. They saw a very large amount of jobs getting stuck. They checked that there are resources available in the cluster, and they run out of source, so they try to restart the resource manager. That can actually resolve the issue temporarily. However, just after several hours, the cluster again goes back to the bad state, and they try to restart, and again it goes back to the bad state. So here's how we went on debugging. So the first question we ask ourselves is, are there any resources available in the queue? This is the schedule UI. We do see there are enough resources available. That's good. The second question we ask ourselves is, are there any resources available for the app? So sometimes if your cluster has resources available, the user may still not be able to run their apps because they may hit the user limit. User limit is a concept in capacity scheduler where it controls how much resources a single user can use. For example, the screenshot below shows the resources for a single user. This user, JHE, has 8 GB max resources, and it has only used 2 GB resources. Another thing we can check is the application headroom info on the application UI. Application headroom means how much more resources this application can use. For example, this is a screenshot for the application headroom. It shows it has 6 GB resources left, which is good. The app has headroom available. Now we can know that this is not a problem of resource contention because we do see enough resources available. Then we use the YARN logs command to get the harm application logs. And from the logs, we found the app is still somehow waiting for containers to be allocated. Now the problem becomes the cluster has free resources. However, the app is somehow not able to use it. Maybe it's a scheduling issue, we suspect. So we try to get the resource manager logs. That was the most difficult part, because users most of the time they are not familiar with the logs layout. Also, one big reason is the resource manager log is usually very huge. It was very hard to do text searching in the logs. And it's even getting worse if you enable the debug level log. Thankfully, in the latest release, we added a new button on the scheduling UI. This button allows the user to dump the scheduling log into a separate file. Basically, once the user clicks this button, the resource manager will write the logs for the scheduler package into a separate file. That makes our debugging life easier because we are dealing with a much smaller log file. So we get the scheduler log file. We look at the log file, and we found there are quite a lot of apps somehow skipped for scheduling. So we pick one of the apps, and we go to the application attempt UI, and we check the resource request table. The resource request table means how much pending resources are, how much pending resources are asked by the app. So like this is an example for the resource request table. So we noticed there are millions of containers asked by the app. Obviously, something is wrong with this app. Usually, it shouldn't ask so many containers. So from there, we try to kill the misbehaving app. All of a sudden, cluster just went fine. So we go and find the user who submitted those apps and stop him or her from doing that. Yeah, so it was big achievements for us so far because we essentially unblocked the cluster. So usually we don't expect our user to be able to fix the problem by themselves because sometimes it's a real bug, you can't do anything about it. So we expect our user to at least identify the problem and have some way to work around the problem, like killing those misbehaving apps. So we went on offline debugging, and we found this is a real product bug. Surprisingly, we use integer for measuring the memory size in the scheduler, and that misbehaved app asks so much resources, and that caused the integer overflow in the scheduler. Everything goes off. So in the YARN 4844, we fixed this problem by replacing the integer with long for the resource memory APIs. What do we learn from this case? Rebooting service can actually solve many problems. That's true. Yeah. So just like something wrong with my laptop, I'll just go reboot it. So thanks to the work-preserving resource manager, learn manager recovery work, now we can restart service without losing any work. Also, another thing we learned is denial service. Like this case, poorly written accidental configuration for your workloads can cause component outages. As developers, we should carefully code against those scenarios. Another example we see from the field is that the user RPC method, like the get queue info, is holding the scheduler log while making connection to the IAM. And in the meantime, the scheduler in the IAM is also trying to acquire the same log, and then those two guys compete with each other. And the user method is being called so frequently that it slows down the scheduler execution. And in turn, that causes other applications to run slow. So that kind of thing is very critical. And also another thing we learned that UI enhancement is quite important. A small change, a very small change in the UI make the life much easier. Like this case, the resource request table is a simple change. However, it was important because we can easily identify which app asks the most amount of resources, and we can easily identify the misbehaving app. Also, alerting is useful. Like this case, if the app asks too many containers, alerting to the user upfront will be very useful. This is another case we got from our customer. So they complain that 10% of their jobs are failing every day, and they rerun their jobs, and jobs finish successfully, and they check all the resource contention problems, and they check there are enough resources while the jobs are running, and they get the logs for the field apps, and they see a lot of mysterious connection errors, like this are unable to read core parameters. I don't know what that means, frankly. So we went on debugging, and we dig deeper into the code, and we try to figure out on the worst scenarios this exception may throw. Still, we don't have any clue, because that's too deep down into the network layer, and that's too much details to figure out. So we requested more field app logs, and we tried to identify the pattern for those app logs. And finally, we just by looking at those logs and doing some graphing, searching, those kind of things, we realized all the apps failed on certain set of nodes. So we asked our customer to disable those nodes, and all of a sudden, jobs just running fine after that. And the customer later on checked their kernel messages, and they found there are disk issues for those nodes. Here's the rule of thumb we learned from this case. Whenever you deal with mysterious connection errors, hum problems, always try to find the correlation between the failed apps and the nodes. We have seen many cases from our customer. If you just disable a few set of nodes, just a couple, most of the cases, your jobs will just run fine. So it's a very affordable action to work around this problem. So that's my part. I will introduce my colleague Xuan. He will demonstrate the most important debugging tool, which is the YARN logs command.
Thank you. In order to figure out why my applications are fail or why my applications are slow, other than just getting the service logs, such as resource manager log, node manager log, or even the ATS logs, it is also very important to get the application log itself. So in YARN, we provide the YARN log command line for the users to get the application logs directly. Here is some useful log command lines. So to get the application log, we need to specify the application IDs. It will actually print out all the container logs for that application. So this command is used for both finished application as well as the running application. To get the specific container logs, we need to specify the container ID. So it will print out all the different log types for that container, no matter this container is still running or finished. Also, sometimes it is very useful if we can get the application master log directly. So we provide another option called -am. By using these options, we could get the application master log for this application. A container could generate multiple different log files. So using the command line, it will output all the different type of logs. But if we try to get a specific log file, we could use the option -log files. Using that, we can help us do that. These options can also support the Java regular expression. Basically, we can just provide a pattern, so it will print out all the log files whose name is matched the pattern. If we have a running application, or my application is very large, so sometimes it's very hard to figure out what's going on. So we have the dash size options can help us to get the first n bytes or last n bytes for the application log. We can always dump the application logs into the local directory, but it will generate a big log files, which include all different types of logs for all the containers. And it is very inconvenient for the users to find out what they really want. Here, we provide a better solution. We can use the out options. In that case, the application log will be dumped into the specific local directory, and we further split the application logs based on the container ID and the node ID of the node managers, which those containers run on. We also provide some kind of log information commands, such as we can do show application log info. It will tell us the current state of the application, all the container IDs for this application. There is another one called show container log info. It will tell us what are the log file names generated by this container. So for next, I would like to demo in a live cluster to show some of the YARN log commands. So I have run a sleep job. So to get this application log, we need to provide application ID. So here we get the application log. Because this application is still running, so by default, we can only get the syslog. So if you want to get the different log files, we can use the -log files. And if we specify the std star, this pattern. So here we could get the stl and stout, which is match the pattern we just given. If we specify the specific log file, say syslog, so it will just give us the log named the syslog. So syslog is pretty large. So if we're using the size options, it will give the either first n bytes or last n bytes. If we specify the positive number, such as positive 1,000, it will give us the first 1,000 bytes of the log. If we provide given the negative 1,000, it will actually give us the last 1,000 bytes of the syslog. Let's try to get the application master log. So we're using the -am options. We specify the 1 as value, which means we try to get the first application master log, container log. So as you can see, the container ID, it is the application master container. So let's try to dump the application logs into the local directory. We just give in the local directory and type it. Let's try to see the. We just create a running folder here. Here is a directory using the node manager's ID. So because I'm running in a single node cluster, so you just see one folder. But if your application is running on multiple node manager, you expect to see multiple folders with different node manager IDs. So you can also see the log files is named as different container. So if you click into the log files, it's where it contains the logs only for that container. So if we closely see the command line, we can see I'm using multiple different options in a single command line. So by using the combination of these options, it will actually help users to get the logs they really want much easier. So this is the YARN command line examples I want to show today. So for details, please check the umbrella Jira in Apache community, which is YARN 4904. So for the next, let's do the summary and introduce some future enhancements.
Yes, thanks, Xuan, for the demo. That demo actually very useful and practical. So yeah, that's all we show today we have for YARN troubleshooting. But in future, it will be more interesting tools to join. First is Application Timeline Service V2. That is umbrella Jira YARN 2928. That we're adding more and more information, including the container matrix aggregation there in the more scalable way. I think that's a part of work. It's just now emerged to the trunk stage, and we are in the community trying to vote in this aim. Yeah, for details, please check another talk, in another room talking about this earlier today. Another interesting thing is new Resource Manager UI. In this UI, we try to expose more information about the containers, the node managers, and how things going there, how container get scheduling. Actually, we're adding more info like from the beginning as a resource request, how tracing all the requests get actually allocated to subqueues, or even why it's not allocated to the other queue, something like that. So all the container lifecycle events get traced there. So actually, it's just like we set up a Facebook for each container. Yeah. Maybe someday you want to live in a YARN world instead of just like containers. Yeah, that's all for today. So questions? Sure. Sorry? Oh yeah, sure. We do have that. We'll put on that. Yeah, maybe. Sorry? Which log? Sorry. Oh, container log. Yes, actually, this YARN log here is including all the. Okay, the question is, can we get the YARN container log? Actually, the log command line here is aggregation of all the containers into a single container file. Actually, the individual container log is cached in the local file.
Oh, that's changed. That's what Sean has done the work.
Yeah, we do have the web interface, but we have a downloading link or something like that. We provide it. Yeah. Sorry.
Yeah.
Yeah, please.
I deal with debugging YARN on a day-to-day basis. One of the problems that we run into is only system admin having a full SSH access where YARN is running is the only place to debug it. Usually, and obviously that's not a viable option for everyone because are there any plans in the future to make YARN logs, resource manager logs, more accessible to some sort of
Okay.
HTTP or because right
Sure.
now everything is proxy.
Okay. Yeah. Okay. The question is, currently is in most cases you have to have a resource manager admin rights to getting the related troubleshooting information. But is that someday in future you can get in more information rather than the admin access, right?
Yeah.
I think for now we are the log command line. For now, it's most like the ARM admin things for now, right? So that is because most of the log is related to the system actually runtime information. So it's typically right because it's supposed to be the resource admin to troubleshooting the root cause. I found the reasons. Even application level you failed, we have application level of log. You should get in some from there. So I think one good thing is if you want to get in application ID, like a specific application ID info, I think for now you can just using admin. Not only have the admin rights, but just application user, you can get the necessary info. Yeah, via this application command line. Yeah, please.
Sorry.
The application request table that you showed, where you could see how many containers your application master is requesting, what version of HTTP is that?
It's in 2.4, I guess.
2.4, yeah.
2.4. Yeah. 2.4, 2.3. Sorry, I don't remember.
Yeah.
All right, thanks.
Yeah.
Is there any way to get the job configuration that's in one or some job that's else?
The job conf is always available on the job history server UI. And for any field app, you can go and click the job conf, and you will get the conf.
But no command line utility.
Not so far, right?
Not so far.
Yeah.
Yeah.
Yeah, maybe we can add in future. Yeah, please.
Any plans to expose the YARN log service to a REST API?
For REST API we do have. So one question is, do you have the ATS enabled? So actually, it's still on the Hadoop 2.9 and HTTP 2.5. We will have that. So basically, you call the web service for the ATS. You can get either running applications or finished application logs. Just REST API is already included.
Which version did you say?
HTTP 2.5.
2.5.
Yeah, the coming release.
Yeah. Yeah, please.
Have you seen any reasons to increase the Java heap size for either the resource manager or the node managers?
You mean include the size of that? I think it depends on the how large a cluster it is. If it's a very large cluster, I think it makes sense to increase some heap size for resource manager because it's tracking more nodes, more applications maybe. So this relate to the class size decide how much memory you have to use. But in the node manager side, most likely you don't have to. I think time is it's up now. If you have more questions, we can talk offline. Thank you.